Hey, we want to take a look at accelerated motion, which is covered by Newton's second law. Let's go back for a quick review on what Newton's first law is. That's also known as the law of inertia, as Galileo referred to it. Okay, and when does that apply? Okay, Newton's first law applies when we have balanced forces. Okay, we can also say that that's when our sum of forces are equal to zero, or you may also see it as when our net force is equal to zero. Okay. What are the two conditions that this applies? Okay, one is when an object is at rest and continues at rest. Another way we could say that is when velocity is equal to zero. And the other condition is when we have constant velocity, or we have no change of velocity. Our initial velocity and our final velocity are the same. Okay. In both those cases, we can say we have no change of motion. Make sure you remember this is change of motion, not no motion, but no change of motion. If there's no change of motion, we have no acceleration. Okay. Let's kind of go back a quick review from our first unit. What is acceleration? An acceleration is the change in velocity, okay, over time, or the rate of change of velocity. Remember, velocity is speed with direction. So at rest, let's do a kind of a quick calculation of this. Our final velocity is zero, our initial velocity is zero, and we have over some time, no matter what we divide it by, our acceleration or our rate of change of velocity will still be zero. Let's take a look at it when we have constant velocity, or constant velocity. We'll take a look at our final velocity minus our initial velocity divided by time. Our rate of change is going to be equal to, well, if our final and initial velocity are the same, that means we subtract those, we'll get zero. So that's equal to our acceleration. Again, our acceleration is equal to zero. Okay. Now let's give ourselves a little more room on this paper, and we'll take a look at when acceleration does not equal zero, okay, or a change in its motion. So when acceleration does not equal zero, that tells us that, hey, velocity or motion is changing. So velocity is changing, could be that it's something speeding up or it's changing direction. In our velocity changes, that means we have unbalanced forces. Unbalanced forces. Okay, and what covers unbalanced forces? We now go to Newton's second law. Okay, so just a reminder that we're talking about unbalanced forces here. Unbalanced forces. Okay. This was kind of a concept that Galileo had a little trouble with. He knew about acceleration and he knew about forces, but didn't really tie those two together. Now we're going to go through and actually take a look at how those two are closely related. Let's take a look at acceleration. Okay. We saw before and from our first unit that acceleration is our change of velocity divided by time. So acceleration is our final velocity minus our initial velocity divided by time, or the amount of time it takes for that velocity to change. In your lab and in the reading, you also saw that acceleration, okay, is related to force. How do I get an acceleration? I push on something, I provide an unbalanced force. Okay, what kind of resists that change of motion? It's the mass, or that inertia. We could also write that as our sum of forces divided by mass. Just a reminder that we could take a look at our final velocity minus our initial velocity. It can also be called our change of velocity. So our change of velocity divided by time is also our acceleration. Okay. Oops, let me correct that. Yeah, so our change of velocity divided by time is our acceleration. Let's set these two equations equal to each other. So we have our change of velocity divided by time is equal to acceleration, which is also equal to our sum of forces divided by mass. Hey, so in good Cornell note fashion, let's when we head on back up to the top of the paper, and we can put some bullet points on this. Okay. Hey, so the first part, it covered Newton's first law, balanced forces, and when do those apply? When we're at rest or we have a constant velocity. Okay. Let's scroll on down just a little bit here. Okay. Hey, how about Newton's second law? We're going to start looking at the conditions where acceleration is not equal to zero. And that's also another way of saying that is when velocity changes or when motion changes. Okay. And how do we end up defining that? Hey, acceleration is our change in motion, which we call our change in velocity, divided by time, the rate of change. But also, acceleration is caused by forces or unbalanced forces. So acceleration is proportional to force and inversely proportional to mass. You may remember that from the lab. So acceleration has a direct relationship with force or net force and an inverse relationship with mass. Okay. Hey, and just a note, probably one of the more famous equations in physics is a rearrangement of this, where we say instead of acceleration is force divided by mass, we multiply each side by mass. We say that force is equal to mass times acceleration.